10.2 Geometry Notes. This section is pretty simple. We have two theorems that I'm going to teach you. The first theorem is going to state if two chords of a circle are equidistant from the center, then they are congruent. So if we have a circle, and let's draw a chord here and another chord over here. I'll try to draw them so that at least they look the same size. There we go, good enough. So if they are equidistant, so we're given that this is congruent to that, then we can conclude that chord AB is congruent to chord CD. So this is our conclusion. The next theorem states the same thing, only the opposite. If two chords of a circle are congruent, then we can conclude that they are equidistant from the center of the circle. So if we have a circle again, and this time we're told that AB is congruent to CD. So if we know that this is congruent to that, then we can conclude that this is congruent to this line. All right, so let's use those theorems to answer a few problems. The first one, if we have circle O, and we know that AB is congruent to CD. They tell us that OP is 12x minus 5, and they tell us that OQ is 4x plus 19. So if we know those chords are congruent, then they're equidistant to the center. Now we know that we can set up 12x minus 5 is equal to 4x plus 19. So I'm going to subtract 4x from both sides, and I'm going to add 5 to both sides. So I end up getting 8x is equal to 24, so x is equal to 3. Now we'll take that information and we're going to find OP. OP is equal to 12x, which is 12 times 3 minus 5. So we get 36 minus 5, which equals 31 for OP. Next problem. A 16 by 12 rectangle is inscribed in a circle. So let's draw a circle. Oops, it's not a circle, is it? Let's draw a circle. And then let's see if I can get this rectangle in there. And let's see if I can move it to fit inside. All right, close enough. So if this rectangle is 12 by 16, this would be 12 and this side would be 16. Now, let's put a mark for the center of the circle right here. And ultimately, we're trying to find the radius of the circle. So the radius we can draw from here to there. And the reason why I did that is because you always want to try to get a right triangle in this shape. And then if I drop this line down, I've now formed a right triangle. With the sides of the rectangle, this would be 8 and 8. And then if I go from here, this side would be 6 because the rest of it would be 6 to add up to 12. So now let's just concentrate on this right triangle inside the rectangle. It is a family, so if we divide everything by 2, we have 3, 4, and then it would be a 3, 4, 5. We'd have to multiply it by 2 to get our final answer that the radius is equal to 10. So let's write radius equals 10. Next. All right, we need to add some labels into these figures on mine. Okay, for this next figure, we have QR is equal to ST, which is 16. So the two chords are going to be congruent. And if we know the two chords are congruent, then we can conclude that UC is going to be congruent to CV. We are also told that CU is 2x and CV is 5x minus 9. We are trying to find the radius of the circle. So if we draw a radius in here, that forms a right triangle if I put it at that point. So we can work with this. Because the chord is bisected by the line going from the center of the circle, this side is 8 on the triangle, that portion is 8. Now we can figure out what this length is because that is congruent, 2x is congruent to 5x minus 9. So when I subtract 5x, I get negative 3x is equal to negative 9, therefore x is equal to 3. If I plug that in, 2 times 3 gives me 6. So 2 times 3. All right. So now I have a right triangle, and the right triangle, if we need to take it out, is 6 for a leg. It has 8 for a leg, and we need to find the hypotenuse, which is also the radius of the circle. This happens to be a 3, 4, 5, because when we divide by 2, we get 3, we get 4, and this would be 5. Multiply that by 2, and our radius is 10. So R equals 10. I'd like you to pause the video and see if you can work out this problem on your own. Here's the answer for the last problem on the notes. We know that the chords are 24, so when you divide that by 2, it gives you 12, which is one of the legs of the triangle. And then 3x is equal to 7x minus 12. So when you solve for x, you should get 3, which makes this side right here 9. So we have 9 and 12, which turns this into a special, which is a 3, 4, 5. When we multiply it by 3 to get back to the correct size, we get a radius of 15. This concludes your notes. You will now work on the problems from section 10.2 in your textbook. When you're done, please make sure that you're correcting your work. If you have problems on any of the homework questions, I have video answers that I've uploaded. It's the same link for every single assignment in chapter 10. I'm just keep adding links to all the problems. So you can even go back and review old problems if you want to as well. I hope everyone is well. Take care.